Batteries aren't just another component of Tesla's plan, they're the foundation of Elon Musk's entire vision for the future. Few people truly grasp just how enormous the scale of global battery demand has become. What was once theoretical is now unfolding in real time inside Tesla's Gigafactory Texas. The facility is alive with activity. Test benches are operating non-stop as Tesla's engineering teams run one of the largest energy experiments in the company's history. Elon Musk's latest announcement marks the start of full-scale production for the next-generation aluminum-ion and sodium-ion batteries, designed for the upcoming Tesla Model 2. This isn't a small upgrade, it's a total shift in how energy is stored, used, and manufactured. If Tesla's internal projections are accurate, the results could change everything we know about electric vehicles, from price and performance to maintenance and lifespan. Imagine an EV priced under $20,000 that can travel 650 miles on a single charge and recharge in just 5 minutes. That's not a distant dream. It's the 2026 reality. It's taking shape on Tesla's production floors right now. And what's more groundbreaking is that these batteries are made entirely with US-sourced materials, using a chemistry that could last decades with minimal degradation. Tesla isn't just building cars anymore. It's rewriting the entire playbook for global energy and transportation. To understand why this is so transformative, we need to dig deeper into how Tesla is managing to shatter China's $150 billion battery monopoly, a dominance that has shaped the global EV market for over a decade. For years, one of the biggest barriers to affordable electric cars wasn't the motors, software, or design, it was the batteries. The average price of a new electric vehicle in the US today hovers around $55,000, putting it far beyond the reach of most families and retirees. The reason? Batteries alone make up roughly 40% of an EV's total cost. Even as American automakers like Ford and Tesla have invested billions into new gigafactories, the essential materials and core battery technologies have still been largely dependent on Chinese companies, most notably CATL, the world's largest battery manufacturer. China's dominance extends across the entire battery supply chain. From mining and refining raw materials to cell production and export, the country has effectively cornered the global electric car battery market. This vertical control allows Chinese EV makers to offer low-cost models at prices Western manufacturers simply can't match. US automakers, on the other hand, are hit with layers of additional costs, raw material imports, tariffs, and transportation fees that add thousands of dollars to each vehicle. For Elon Musk, that dependency is unacceptable, and it's exactly what Tesla is now eliminating. Musk's strategy centers on one bold move: removing lithium, cobalt, and nickel from future EV battery production. These materials are expensive, limited in availability, and deeply tied to China's industrial ecosystem. Instead, Tesla is pivoting toward materials that are cheaper, safer, and more abundant, specifically aluminum and sodium. This isn't just a material substitution. It's a complete rethinking of how energy storage works at a national scale. By doing so, Tesla is addressing three of the most critical weaknesses in the current global battery supply chain: price volatility, supply disruptions, and geopolitical leverage. Let's start with price volatility. Lithium prices have been wildly unstable in recent years. Between 2021 and 2023, the cost of lithium carbonate surged from around $15,000 per ton to an astonishing $80,000 per ton before dropping again. This extreme fluctuation makes it nearly impossible for automakers to predict long-term production costs. Every battery cell becomes a financial gamble, affecting not only EV pricing, but also profitability and investor confidence. By transitioning to aluminum and sodium, Tesla sidesteps this chaos entirely. Both materials are abundant, locally available, and far less susceptible to international price swings. The second issue: supply chain disruptions became painfully clear during the 2022 Shanghai lockdowns. When one region shut down, global EV production nearly ground to a halt. Batteries couldn't be shipped, raw materials were delayed, and entire supply lines collapsed overnight. Tesla experienced firsthand how dangerous it is to rely too heavily on a single country for critical manufacturing. The new domestic battery strategy solves this by creating an independent, self-sustaining supply chain within U.S. borders. Instead of importing critical materials, Tesla is reactivating America's own industrial potential. That brings us to the third factor: geopolitical leverage. For years, China's dominance over lithium refining and cell production has given it enormous strategic power over global industries. According to the International Energy Agency's 2024 report, China currently controls roughly 77% of global lithium refining capacity and 60% of all lithium-ion battery production. This means that even if a U.S. company assembles its batteries domestically, it's still dependent on China for essential materials. Any trade restrictions, policy changes, or international disputes could disrupt the entire market. By pivoting to aluminum and sodium, both of which are abundant in the U.S., Tesla effectively eliminates this risk. For the first time, America could produce world-class EV batteries without depending on a foreign supply chain. The aluminum pathway, in particular, is one of the most intriguing parts of Musk's strategy. The U.S. already has a massive aluminum infrastructure, much of it underutilized since the 1980s. When cheap imports caused domestic production to plummet, large reserves of bauxite, the primary or used for aluminum, exist in states like Arkansas, Texas, and Georgia. These resources have been largely dormant for decades. But now they're poised to become central to a new era of energy independence. With rising national security concerns and legislation, like the CHIPS and Science Act, promoting domestic material sourcing, these once-forgotten reserves have suddenly become strategic assets. Tesla's approach leverages this underused potential. By partnering with companies like Alcoa and Century Aluminum to major American aluminum producers, Tesla is laying the groundwork for long-term supply agreements that could reopen old smelting operations and revitalize U.S. mining regions. These partnerships don't just ensure a steady stream of materials. They also align perfectly with government incentives for sustainable domestic manufacturing. Every battery built in America using American materials strengthens the country's energy security while reducing reliance on global shipping networks. But aluminum-ion technology isn't just about politics or economics. It's about performance. Aluminum, as a material, holds nearly 3 times the charge density of lithium, meaning it can store far more energy in the same physical space. It's also lighter, more recyclable, and less prone to overheating. When combined with Tesla's proprietary cell architecture and energy management software, aluminum-ion batteries could deliver previously unthinkable performance, 1,000-mile ranges, charging times measured in minutes, and lifespans exceeding several decades. Meanwhile, sodium-ion batteries, the complementary branch of Tesla's dual chemistry approach, are being optimized for affordability and cold weather stability, ideal for entry-level EVs like the Model 2. Together, these two chemistries form a powerful 1-2 punch. Sodium batteries bring low-cost scalability and thermal stability, while aluminum-ion packs deliver ultra-high energy density and fast-charging performance. This combination gives Tesla the flexibility to match different battery types to specific vehicle models and use cases. High-end vehicles could feature aluminum-ion packs for extreme range and performance, while mass-market cars could rely on sodium-ion cells for affordability and durability. It's a modular, adaptable approach that makes Tesla less vulnerable to single material shortages and keeps production costs stable inside Gigafactory Texas. Engineers are already putting these systems to the test. Specialized rigs are simulating millions of charge cycles, pushing the new cells to their limits under extreme conditions. Early data suggests that these batteries can maintain over 90% capacity even after decades of use, a level of longevity that could redefine what vehicle lifetime means. Imagine owning a Tesla that doesn't need a new battery for 30 or 40 years and can recharge faster than you can fill a gas tank. That's the paradigm shift Elon Musk is betting on. the broader implications are massive. Affordable EVs would no longer depend on rare minerals or fragile trade relationships. U.S. factories would gain new life as domestic aluminum and sodium production ramped up. Entire regions in the South and Midwest could experience an industrial revival, fueled by clean energy and advanced manufacturing. At the same time, the consumer benefits are impossible to ignore: lower prices, faster charging, longer range, and dramatically lower maintenance costs. The dream of a truly affordable, high-performance electric car could finally become reality. Tesla's move isn't just about cars. It's a declaration of technological independence. By controlling its entire supply chain, from raw materials to final assembly, the company is building a model that others will struggle to copy. Traditional automakers still rely on complex networks of suppliers, many of them overseas, which limits their ability to pivot quickly. Tesla's vertically integrated system gives it total control over production costs, innovation speed, and material sourcing. That's why legacy manufacturers, even with Massey,